Let's have a look at this workflow created to solve a classification problem. First we read the data, then we do some pre-processing, and finally split the dataset into a training set and a test set. Next, we train a machine learning model and apply the model to the test set. Finally, we evaluate the model quality by measuring the correctness of its predictions. There are many performance measures to evaluate model quality. Each one has its pros and cons. A well-established performance measure is the Receiving Operator Characteristics Curve, or in short, the ROC curve. The ROC curve uses the false positive rate and true positive rate obtained by applying different threshold values to the positive class probabilities predicted by the model. The threshold determines which data are assigned to the positive class. The lower the threshold, the more data points are assigned to the positive class. For this workflow, we use customer data to predict credit scores. The target column score has two possible values, good for safe and bad for risky customers. So this is a binary classification problem. To build an ROC curve, we use the ROC Curve JavaScript node. Like all JavaScript-based nodes, it produces an interactive view. The ROC Curve JavaScript node has already been configured and executed. Let's open the view from the context menu. The x-axis shows the false positive rate and the y-axis the true positive rate. The positive class can be arbitrarily chosen. Note that here the positive class refers to the credit score bad. The blue line, the ROC curve, shows the model quality as described by these two measures. For example, for this threshold here, 80% of the risky customers will be classified correctly, while 15% of the safe customers will be classified incorrectly. A random classifier would produce this black line. These statistics here show the area under the curve. The closer it is to 1, the better the model performance. A random classifier would produce an area under the curve of 0.5. As in all JavaScript node views, this button up here is for changing the graphic properties of the view. The ROC Curve JavaScript node has 2 input ports and 2 output ports. The input data must include 1 column for the actual class values and at least 1 column for the predicted positive class probabilities. These columns are provided here by the predictor node. We need this optional input only if we want to change the colors of the curves. The first output, if enabled, is the ROC curve as a static image. The second output is the value of the area under the curve. Let's now take a look at the configuration options. In the ROC Curve Settings tab, we first select the class column containing the actual class values. In this case, it's the score column. Now we define the positive class value. We said we refer to the bad class as the positive class. We set that here. Next, in this Include/Exclude framework, we select the input column containing the probability for the positive class prediction. In this dataset, it's the p score equal to bad column as produced by the predictor node. By checking this option, rows with missing values in the target class column score will be ignored. Otherwise, they will appear as incorrect predictions at the right end of the ROC curve. Drawing an ROC curve can be computationally expensive due to the calculations of the predicted classes using varying thresholds for the probabilities. In order to avoid too long computation time, we can restrict the number of input data rows used for these calculations in this field here. We can of course change this number, which is by default 2500. And if we want to use all of the data regardless of their size, we can type -1 here. In this video, we have used an ROC curve to evaluate the quality of a classification model. We showed how to interpret the curve, how to configure the node, and how to change the visual appearance of the resulting interactive view. The node also produces the area under the curve and a static image of the view in its output ports. Notice that you can also use the ROC curve to evaluate a multivariate classification model. Then you refer to one class as the positive class and to all the other classes as the negative class.